The formation of the solar system is a complex and captivating process that scientists have been studying for centuries. It began around 4.6 billion years ago from a vast cloud of gas and dust known as the solar nebula. This nebula was likely triggered by the shockwave from a nearby supernova or some other disturbance in the Milky Way galaxy. One nebula formation. The solar nebula consisted mostly of hydrogen and helium, along with traces of heavier elements like carbon, oxygen, and nitrogen. These elements were left over from previous generations of stars that had lived and died before the formation of our Sun. 2. Collapse. Some event, such as a nearby supernova explosion or a shockwave from a passing star, caused the nebula to start collapsing under the influence of gravity. As it collapsed, the nebula began to spin faster and flatten into a rotating disk due to conservation of angular momentum. 3. Proto-Sun formation. At the center of the collapsing nebula, a dense core formed, which eventually became the Sun. As more and more material fell into this core, its temperature and pressure increased, eventually triggering nuclear fusion and igniting the Sun. 4. Protoplanetary disk. Surrounding the young Sun was a swirling disk of gas and dust known as the protoplanetary disk. Within this disk, small dust grains collided and stuck together, gradually growing into larger and larger objects through a process called accretion. 5. Planetesimal formation. Over time, these small particles clumped together to form larger bodies known as planetesimals. These planetesimals continued to collide and grow, eventually forming the planets, moons, asteroids, and comets that make up the solar system. 6. Terrestrial planets formation. In the inner regions of the disk where temperatures were high, only rocky materials could condense. This led to the formation of the 4 terrestrial planets: Mercury, Venus, Earth, and Mars. These planets are relatively small, dense, and composed mainly of rock and metal. 7. Jovian planets formation. Further out in the disk where temperatures were cooler, ices could also condense along with rocky materials. This allowed for the formation of the gas giants: Jupiter, Saturn, Uranus, and Neptune. These planets are much larger than the terrestrial planets and consist mostly of hydrogen and helium, along with other gases and ices. Migration and resonances. As the planets formed, gravitational interactions between them caused some to migrate inward or outward from their original positions. These interactions also created resonances, where the orbital periods of planets are related by simple fractions, such as 2-1 or 3-2. 9. Formation of moons and other bodies. Many of the moons in the solar system formed alongside their parent planets, as smaller objects in the protoplanetary disk were captured by the growing planet's gravity. Other bodies, such as asteroids and comets, are remnants of the early solar system that never accreted into planets. 10. Late heavy bombardment. After the planets had formed, the solar system experienced a period of intense bombardment known as the late heavy bombardment, around 4.1 to 3.8 billion years ago. During this time, leftover planetesimals and debris from the early solar system bombarded the planets, leaving impact craters that can still be seen today. 11. Stability and evolution. Over billions of years, the solar system has evolved into the stable configuration we see today. While small changes and interactions continue to occur, the overall structure and dynamics of the solar system have remained relatively stable for millions of years. This overview provides a glimpse into the remarkable processes that led to the formation of our solar system, a cosmic journey that continues to inspire curiosity and exploration.